This is a video for the Ask Karamoon project. My friend Jared asked about the best ways to teach kids to code. Not sure why he's asking this, because Jared is much, much cleverer than me and infinitely better at programming than me. But I think my kids are a bit older than his, and I've been teaching my son to code. So I have lots of thoughts on this kind of thing, and I shall explain some of them. So obviously there's like, what language do you choose? There are now a whole bunch of languages designed for kids, things like Scratch, which is the language I've been doing with my son. There are kind of environments for kids using, let's say, real computer languages, although I use that term lightly, particularly as the language I'm thinking about is Python, which is an utter disgrace. So I'm doing Python with my son Edward, using the kind of the paradigm of making stuff in Minecraft. So Minecraft, at least Minecraft Pi, which is the Minecraft that runs on the Raspberry Pi, that has a Python API. So we are writing little Python scripts that do stuff in Minecraft. So there's obviously choice of language. There's also choice of what you do in the language, what kind of projects or whatever. Just on that point, I'm a very, 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 very big believer in parsing text as kind of a beginning programming projects. Really, really big believer in that. Write a text adventure. Just get the kids thinking about, user types in a sentence. How do you, use whatever string handling your programming language has, or if it's C, there's no string handling, but of course there's, in the C standard library, you've got a bunch of string functions. How do you break apart that string, compare different bits of the string with some words stored in an array to try and understand, what the user wants to do. Another really good kind of related thing is code breaking tasks, looking at letter frequencies and stuff, just solving some of the very basic Caesar shift cipher or whatever. So choice of language, choice of what you do with it, and maybe more important than anything else, choice of how you teach it. Although, there really is something more important, which is, what do you teach about programming? We have to be at the starting point of saying, we do not know much about making software, right? Humanity does not know much about making software. Okay, how can I say that? How can I say that so strongly? Well, look at software. It is pathetic. Almost all software is unfit for purpose. It's junk. It's junk for lots of reasons. It solves the wrong problems, or it tries to solve the right problems but badly. Often it's completely built in the wrong paradigm. I'm not talking about OOP or functional or probabilistic or whatever, procedure or whatever, just the wrong paradigm, in that we're very bad at thinking what software should present in terms of a solution. I saw a wonderful quote recently, a quote I've seen a couple of times before, but just this Dan Ingalls quote that the operating system is all the stuff that doesn't fit into a programming language, and there shouldn't be one. That's a very, very, very powerful starting point for thinking about programming. So one thing I think really is really important is to get kids thinking about what they'd like to be able to do that they can't do now, or that's difficult to do, and then maybe prototyping that on paper. And in the beginning, just prototyping the problem itself, not rushing to prototype a solution, but just paper models of organising a picnic, for example. What are the different steps involved? What stuff could be done at the same time? What, get your little critical path. What stuff can only be done when another thing is already done? How stuff changes as new information comes in. Like 3 kids want to bring their brother or sister or whatever it is, or some parents want to come along. So map that out with bits of paper, post-it notes, overlays. So many, you see the people look at crap at doing prototyping, right? You want coloured strings, you want clear plastic for doing overlays, particularly when you sort of come to look at user interface stuff. So there are different ways of thinking about like a model of what programming is. So think about Simon Papat when he was teaching using the Logo language that he kind of designed. He would teach the kids that programming is teaching the computer how to do stuff. So he would get the kids to make a little procedure in Logo that draws a spiral. And he'd say, you've now taught this computer a new word, spiral, which should be the name of the procedure, the function. And you've kind of taught it how to do this thing. And now you can use that word as like a part of the vocabulary and make other functions that involve that word. So maybe a little function that calls that word 3 times with a turtle in different positions on the screen, and there's a little stalk, and makes a kind of cool little flower. And you'll call this flower. And now you've taught the computer this other thing, so now the computer knows how to do a flower. Or then you can have another procedure that calls that a few times and makes a little cluster of flowers, and maybe let's have it random. And then so you've now got this thing called cluster flower, and then another procedure that calls that a bunch of times and makes a garden. So you now got this thing where you can just plant down a garden. That's a very, very powerful way of talking to kids about programming. I quite like the Knuth's idea. He said, programming is explaining to a human how a computer would do a task. I think that's quite good. It does reveal how badly computers are designed at the API level, at the OS, at the hardware abstraction layer. It's all crap. But I think that's a very useful thing, and you must teach kids how to think and talk about programming, right? That's really, really important. Give them this. This is the language that they should be learning at school, just like again, go back to Seymour Papert. Why are kids so bad at mathematics? Well, why are adults so bad at mathematics? Well, it's the same reason that humans are bad at thinking, that we don't have a good language for talking about thinking. My daughter is 3 years old, going to be 4 quite soon. She is now developing language for talking about language, and it's resulting in exponential growth in how she talks. And I would argue very, very strongly it's probably resulting in a great deal of growth about how she thinks. So just knowing sentences like, what's the word that means the opposite of blah, blah, blah. What's the feeling when blah, blah, blah. This like meta language is so powerful, and you only need a tiny bit of it to make a huge difference. Well, we really need kids to have language that talks about programming, that talks about debugging, particularly that talk about structure. We have to go back to these really fundamental ideas, like programming is about taming complexity. Like every programming language is really a response to complexity. If you're doing a small one-off task, which I argue often you're not, whatever you're doing, it sadly tends to hang around a lot longer than it should. But it doesn't matter what language you use. Think of all the junk people write in Python, Perl scripts, whatever, a quick and dirty kind of bit of bash, all that stuff. That doesn't matter because it's tiny stuff. But generally we want to do bigger things, and stuff gets complex surprisingly quickly. So a lot of it is like, how do we deal with complexity? Other things we need to be teaching the kids is what's going to happen in a year's time when you look at the code. Now that brings up a very controversial point of sort of should code be commented? Is it the case that if you're having to comment your code, then your code's not clear enough, or that the language itself, the syntax is not fit for purpose? What happens when you're doing Lisp, and again, like think about the philosophy of Lisp, where you're sort of solving a problem by making a domain-specific language for that problem. You could say one of the massively strong point, that's like the strongest point of Lisp, but it also results in a thing that Lisp is quite hard for non-Lispers to read. Another really important thing we need to teach kids is I'm afraid remember what it's called, but this phenomenon that as a piece of software becomes more powerful, it gets to a point where the software is basically a bad version of the language it was created in. So let's imagine that your kids made a little game in Scratch, and so they made like a racing game in Scratch, and then they've added a racetrack editor and a little sprite editor so you can design your own character. And your racetrack editor and sprite editor are probably going to be simplified versions of the graphics editor that's built into the Scratch IDE. So that's a really, really important thing for kids to understand. is like, when do you get to the point where the application is kind of defeating the purpose, defeating its own purpose. I guess one really fundamental thing to say is you need to always remember that when you're teaching a language or learning a language, that is not the same as learning how to program. And the really easy way to just get around that from the beginning is 2 languages at once. So in the kind of educational programming community in the UK at the moment, there's this kind of idea of moving from scratch to Python or whatever. And that's a stupid idea held by idiots, quite frankly, because the thing is not the moving from one language to the other. The thing is doing both languages at the same time, not thinking about moving from one language to the other, but thinking about deepening your understanding of the language. So, this is why big boys and girls are taught to learn languages that you're not going to use. They say, use C++ for your job. Spend some time learning Eiffel. Make you a much, much, much better C++ programmer. Look at, you're doing Java for your day job. Go and spend your weekends doing Smalltalk. Go and look at, I always forget the name, is it Oak, the language that Java came from? And then you're seeing what Java should have been before the managers at Sun Microsystems screwed it up. Kind of as a side point, but leading into a bigger point, every single person who codes absolutely must, spend some time doing C with a debugger and just looking at how it compiles to assembly. And turn obviously make it, turn off all the compile optimizations or whatever. But just going through little code snippets and just seeing what happens. And then the kind of bigger version of that, which feeds on the previous point of doing 2 languages at once, is look at typical idioms in a language. And look at them in terms of another language. So any good book on assembly is going to have probably an appendix of comparing assembly idioms and C idioms. And it's just time really, really well spent. And you might learn some surprising stuff about your main language. I love that story about the Gang of 4 book on design patterns. I'm ashamed to say I haven't read it. I'm actually don't really know C++, so I would probably struggle with it. But I think it's like 23 design patterns or whatever. And someone wrote a rebuttal of the book basically pointing out that 13 of the design patterns are unnecessary if you use a real programming language. In their case, they were about Lisp. Like 13 of these design patterns out of the 24 were redundant in a real programming language, which is really funny. I love that Alan Kay quote where he said, "I came up with the term object-oriented programming, and I certainly didn't have C++ in mind." And a practical version of that is get one of those cookbooks, Python code breaking cookbook, or C++ web design recipes, or whatever it is, and go through each example in another language, at least one other language. It's a really, really lovely thing to do with the kids. You get one of those little cookbook books, like an O'Reilly cookbook or whatever, and just go through the examples and think, how would I do this in another language? Okay, I hope some of that was useful. Yeah, I like playing around with Scratch with my son. There's a lot wrong with it. Not least the fact that the current version 2, is written in Flash, but the previous version is written in Smalltalk using the Squeak environment. We're told version 3 is going to be written in HTML5, so that will be hopefully a big leap forward from HTML. I think my impression was that with Scratch and Squeak, it was like getting it to a point where they'd have to fix a whole load of stuff in Squeak to make it a really practical language. So yeah, good. Hope that's useful. Awesome question, Howard. Thanks a lot for that. And obviously I'm going to leave you with an Alan Kay quote. He said something like, he said, everyone's saying we need to teach kids to think like programmers, and this would be a terrible thing because programmers are crap at thinking. It's the last thing we want. Thanks for listening. My donation link is matthewdons.org, MATTHEWDONS.org. Thanks a lot.